So this video goes along with the material that's in lesson 4.3 in your textbook, which is about modeling with quadratic functions. And what we're going to take a look at in this video is how to write an equation of a parabola. So if you think back to what we talked about when we were discussing linear functions, we were able to say that if we were given 2 points on our line, any 2 points, we could write the equation for the line. Now that we are dealing with parabolas instead of lines, we need more than just 2 points. We actually need 3 points in order to define our parabola. And if you think about the general shape of a parabola, whether it's opening up or opening down, that should make some sense, because if you're only given 2 of the points on your line, you don't have enough information to figure out where the other side of the parabola might be going. So even if you were given these 2 points here, maybe there and there, you wouldn't have enough information to figure out what was going on the other side of the parabola. Or if you were maybe only given, let's say, this point and this point, you would have no idea if the points just connected to each other through a straight line, or if the parabola maybe opened down, or if it was a very shallow opening, or if it dipped far below where the actual parabola is. So again, in order to define a parabola, we need to have 3 points. So we're going to work through an example that does just that. It gives us 3 points that are on our parabola, and we are going to use those 3 points to figure out what the equation is for our parabola. And in order to do that, we're going to use the standard form of a quadratic equation. And just to refresh everyone's memory, standard form is y equals ax squared plus bx plus c. And just for simplicity's sake, I'm going to number each of these points. The point 0, 0 will be number 1, this will be number 2, and here's number 3. So what we're going to do is we're going to take the coordinates for all 3 of these points, and we're going to plug them in to the standard form of our quadratic equation. So point number 1 is the point 0, 0. So that means when we plug those coordinates into our standard form, we're going to get the equation 0 equals a times 0 squared plus b times 0 plus c. For equation number 2, I'm going to plug negative 2 in for y, and we'll have a times 1 squared plus b times 1 plus c. And then for point number 3, we'll have the equation negative 4 equals a times negative 1 squared plus b times negative 1 plus c. So again, all I've done is I've taken each of our 3 points that we were given for this particular parabola, and I've plugged the coordinates for those points into the standard form for a quadratic equation. Now that I've done that, we can simplify each of these equations a bit, especially this first equation. We're going to end up with 0 on the left side of our equation, but a times 0 squared, that of course cancels out, as does b times 0. So that's pretty nice, because that tells us then that c is equal to 0. So that's helpful. Let's simplify our second equation a bit. This says negative 2 is equal to a, since 1 squared is just 1, that just becomes a, plus b, since b times 1 is 1, plus c. And then our last equation is going to be, actually, I'll write that down here. Negative 4 is equal to a times negative 1 squared, but if we square a negative number, that of course becomes positive, and negative 1 squared will just be positive 1, so this is just a. B times negative 1 will become minus b, and then plus c at the end. So really what we have here now is a system of 3 equations, which is something that we just finished talking about in chapter 3. And since we have 3 unknowns, but we're given 3 equations, we should be able to figure out the value for each of our 3 unknowns. And luckily, in this particular case, we got very lucky, and we already know the value for c, and that it's 0. So since I've run out of room on this slide, give me a second, I'll copy all of this information over to the next slide. So we know that C is 0, and then we need to work with our other two equations. We know that A plus B plus C is negative 2. And then we also know that A minus B plus C is negative 4. And so we're going to need to use some of the strategies that we learned in Chapter 3 for solving systems of equations. Now, based on the way this system is set up, this is not going to be too difficult. We're going to start off by using substitution, and we're going to substitute that value of C equals 0 into both the first and the second equation, which will, of course, simplify our lives considerably. So that first equation will just become A plus B equals negative 2, and the second equation becomes A minus B equals negative 4. And now, hopefully, the bells are going off in your head, and you can easily see that we can solve this system using elimination. And you can either choose to add or subtract these two equations. I'm going to go ahead and add them. So we'll have A plus A, which is 2A, B plus a negative B, of course, will cancel out, and negative 2 plus a negative 4, that will give us negative 6. And if we divide both sides of that equation by 2, we can figure out that A is negative 3. Now that we know what A and C are, we just need to figure out what B is. So I'm going to plug our value of negative 3 for A into this equation here. So that means negative 3 plus B is negative 2. And if I add 3 to both sides of this equation, we can solve for B, and that means that B is 1. So let's write down again what we know. We know that A is negative 3, B is 1, and C is 0. And once you know all three values for A, B, and C, then you can go ahead and write the standard form of your quadratic function. Remember that, I'll write this down one more time, although you should know it by now, standard form says y equals ax squared plus bx plus c. So I just need to plug in A, B, and C. So we get y equals negative 3x squared plus 1 times x, because b is 1, so that's just plus x. And then since c is 0, don't need to write anything there. No, that's not very nice. Just a second. Okay, that looks a little bit better. And we've got our final answer. So our equation in standard form is y equals negative 3x squared plus x. Tells us that A is negative 3 and B is 1.